Hey guys, welcome back to the Geography Academy. Remember, this video is just a small part of a much larger course that's available below if you just follow the links and instructions. Okay, next up is atmospheric hazards. So atmospheric hazard broken into two main distinctive groups: tropical storms, which is our large-scale atmospheric hazard, and a small-scale atmospheric hazard, which is our tornadoes. So we start off with tropical storms, and we have to think about the formation of tropical storms first. So they start in areas in the tropics, kind of give away with the name, and inside of the Tropic of Cancer and Capricorn, more specifically. So they begin here because of the high sea temperatures. Those temperatures being, about 26 degrees Celsius and above, with 50 to 60 meters in depth. This gives it the heat energy it needs, and this creates then a rise in the air. The air then is going to rise, and it's going to cause then the force of the air to rise up with a low pressure here. So less dense air rises, and then it cools, and then it circulates and comes back down. So we need a low pressure system to build up so air can rise. As air rises, it condenses then and forms clouds higher up in the atmosphere. This low pressure air then brings all the moisture up with it and begins to create storm clouds with it. When it's going through this process, then it begins to circulate and it starts to form these storms. So when this forms out into the sea in the tropical areas, this begins to create then a low pressure system that will build up. So the continuation of the warm, moist air coming from the sea causes the tropical storm to increase its power and the pressure to get lower. As the lower pressure continues, air from around it moves towards the low pressure area, right? So when you think about it, you've never been standing in an area and suddenly there's no oxygen. So it's like a kind of conveyor belt style, where as the air moves up, it's also dragging in air from the other regions as well and causing it to rise into a low pressure system and a storm to develop. So that's what's happening there. The Coriolis effect then is created because the Earth is spinning. Because the Earth is spinning, that means that the air then, because of friction, is pushed away from the equator, so it's not going to move directly or stay in the same location. So this causes the storm to move away almost exactly. This means a low pressure system can never build up to a tropical storm size at the equator, which means that we don't see tropical storms forming 5 degrees north and south of the equator, even though tropical storms happen in the tropics, which are right beside the equator and up to the equator. So that is roughly the location of it. It begins as a tropical depression, a low pressure system that builds up to wind speeds of up to 40 miles an hour. And then we see the tropical storm stage moving up to a kind of 63 to 118 kilometers per hour and creating this circulation. Now it's formed a stability. It's building up. As long as it maintains its location over a warm body of water in a deep ocean, it will continue to increase, or it can often. It doesn't always, and this is why not every low pressure system becomes a tropical storm. So it has to have those correct positions. So as it starts to spiral structure then and starts to move away from the equator in the north and the south hemisphere, both happens there, it can increase if it has favorable conditions as well. This means that it has low wind shear, which means not as much wind coming in to disrupt the pattern of air rising, and a warm water supply. So all of this is measured then on the Saffir-Simpson hurricane scale, which goes up to a category 5, which is anything 252 kilometers an hour plus. These extreme winds then can cause a lot of damage. So high winds are the first threat that come with the tropical storm: structural damages, power outages, and uprooted trees. We can see storm surges then increasing and causing huge coastal flooding and lots of damages along there. Storm surges are caused because you have the wind, and the consistent wind that's pushing the waves and creating large waves that move inland and are continuously high for that period. So tropical storms might take many days in order to reach its target area and to make landfall. As it's making landfall, then it's going to decrease because the water, the fuel source basically for it, has run out. So if it's not over the sea, then it's going to die down. So as it's moving from the ocean into a mainland area, it will continue to get stronger, which increases the storm surges waves that are moving towards it. So you have coastal flooding due to this, but also because of the prolonged precipitation. So when you think about it, there is going to be as much precipitation over the days which the storm is reaching the coastline. The rainfall is then increasing in its intensity and its frequency. So this causes all the stores in the ground to begin to be filled with water. So your soil water store, your vegetation store, groundwater, surface store, channel store, all of these water stores in the drainage basin are going to fill up. And this means that most of the water then that falls as precipitation after a few days is going to lead to direct flooding and surface runoff or overland flow. This can create then river flooding, increase the impacts on coastal flooding as the river is trying to leave the system. It's moving out towards the coast. It can get blocked at that estuary and then build up to make a bigger flood. Landslides then can then be created due to the saturated soils and the addition of water, decreasing the sheer strength of the slope, creating landslides. The distribution then we can see usually the storms then are coming from this area close to the equator, and then they're moving across and then moving up, and on the other side they're moving across and down like that. So the two move in opposite tracks in opposite directions. They increase in size and scale, and then they decrease, and then other winds can take them in different directions. So they start off weaker, build up stronger, hit landfall, and then usually we don't see them very strong over the land. And this is because they run out of their source of energy, which is the warm water. So they decrease in size and scale, but they can still be a low pressure system causing precipitation and high winds. This is why sometimes areas in other parts of the world, like over in Europe, they get the tail of a hurricane